All right, next we are going to get into something a little bit different. It's going to be hard to see the connection between angle of elevation, depression, and this stuff, but they are connected. Just take my word for it. So these we're going to be talking about something called arc length, which I'm trying to write arc length. So write that down, arc length. Basically, an arc length is the distance around part of a circle. So you can kind of see from the pictures here, it's either all the way around, part of the way around, 3/4 of the way around, half the way around, those kind of things. But really an arc is just like partially. So if you kind of start here and you start walking around a circle, you've gone around the arc, and once you stop, you stop. So it may not be the full distance, it might be part of the distance. And a quick pop quiz, what is it called when we talk about the distance all the way around a circle? It's not, I almost said the other one, but it's not what? Come on, think about it. If you're walking around like a square or a rectangle or like a field or something like that, you call it a perimeter. It's kind of like perimeter, but it's not called perimeter because when you're dealing with circles, it's actually called a circumference. Okay, so the circumference, so you will need that. Let me at least write that up here so you can write that down. You'll need a circumference because you need to know what a circumference is. So a circumference, usually I get snickers when I say circumference in class and people laugh, but on the video, no one's laughing. Circumference. A circumference of a circle is the distance around the circle. Around a circle. Okay, so that's the circumference. So an arc length really is just a piece of the circumference. But the formula for the circumference is C equals 2 pi r. So 2 times pi times the radius. And once again, the radius is the distance from the center of the circle to the outside edge. So on my little picture here, distance from the circle to the outside edge, that is the radius. Radius. Okay, there's my radius. So if you know that distance, you can figure out the circumference. Another way of writing this is, since it's 2 pi r, well, what's 2 of the radius? And you're right, it's called a diameter, so you could also write it as pi times the diameter. Same formula, 2 different ways of looking at it. You can use either one, doesn't matter. All right, so let's try to figure out a little bit how we calculate this idea of an arc length. So we know the circumference, and it even gives it to you, the first thing there. So if you go all the way 360 degrees around, so you start here and you go all the way around and get back. You went 360 degrees. The distance you would travel is 2 pi r. That's the distance. It's the circumference, okay, the whole thing. Now let's bring it back a little bit. Say, well, what if we did something like this? So we went 270 degrees around, which, by the way, is 3/4 of the way around. You start here, you walk here, it's 90 degrees, 180 degrees, 270 degrees. It's 3/4 of the way around. But think about it in terms of degrees. So if you take this and you went 90 degrees, then you broke it up into individual little pieces. You went 90, 180, 270. 270 out of what, though? What's the total amount? You say, oh, it's 360. So really, you take that, the 2 pi r, which is the whole thing, and you multiply it by how much you actually did, because we didn't complete the whole thing, just part of it. In fact, how much did you did? You could say 3/4. By the way, you'd be right. However, let's just, for the sake of this investigation, let's not reduce everything yet. We went 270 out of the 360, right? That's how far we actually went. So if you multiply this through, you end up with a nice little fraction where, if you say, well, how do you multiply fractions? Well, you take this and put over 1 because it's a whole number, and you multiply straight across. So I'm not going to reduce yet, and you'll see why in a moment. So you have 2 pi r times 270, and the whole thing is over 360. And if you put that in your calculator, with, you knew what r was, then you would get the answer of how far you actually walked. So whether you walked 1 mile or 10 miles or whatever the radius is, you just put the r in there and it'll grow depending on how far you went. So if the radius of a circle is, like, let's say 3 miles, you put a 3 in there and that tells you how far 3/4 of the way around is. It's pretty, actually kind of cool and powerful that you can even do that. But anyway, maybe you can apply that sometime in your life. Now let's talk about 180. So now we're going halfway around the circle. So once again, we went 2 pi r if we did the whole thing, but we didn't. So if we did half, you could say multiply by 1/2. But once again, for the sake of this investigation, let's say that we're just keeping it in terms of a non-reduced 180 out of 360. And what that will do is that'll give you the similar formula. You'll notice it's 2 pi r times 180 out of 360. Okay, and once again, you can do the same thing. If you knew what r was, you stick it in there, you multiply it in your calculator, you do it in your head, whatever you can do with pi, and then you get the final answer there. You should start noticing a trend. 2 pi r, 270, 180. They're both being divided by 360, so the only thing that changes is the angle, the interior angle, or how far you're walking around the circle. So let's keep going and see if that applies. So I'm going to start, let's do this step one more time. So 2 pi r is the total distance. And we're going to multiply by how far we're going around. And you say, well, that's 1/4 of the way around. You're right. It's also 90 out of 360 because that's how far we actually walked. So 90 out of 360. And that gives you same formula, 2 pi r times how far you went around divided by 360. So you start noticing a pattern here. What's the next one going to be? Try it on your own. Maybe you can even skip a step. That's fine. Should be something like this. And I want you to pause, try it on your own. Okay, now you can press play again. So 2 pi r times how far did you go around? 45 degrees out of the 360. And there's your formula. You should get that pattern by now. What's the last one? So I probably don't have space, so I'm going to write it here. 2 pi r times 1 this time, because it's 1 degree out of 360. So there's your formula. And the overall formula, the reason we get to this step, this is, by the way, called the abstraction. This is when we take our process all the way down and say, okay, now let's apply this to any angle measurement, regardless of what you have. And so we're using angle alpha. It's not an A, it's a Greek letter alpha. And so basically what we're coming up with here is the formula for arc length. So it's 2 pi r times, so 2 times pi times your radius, times angle alpha. Now, what is angle alpha? It's the amount of degrees of the interior angle. So if you opened up your circle at 18 degrees, it's 18. If you open it up to 32 degrees, 32, whatever it is, alpha divided by, you guessed it, 360. And that's how you come up with abstract or generalized cases. So that's where that comes from. So now let's go down and actually see what we do with this. Because there's a lot of application that we're not going to get to all the application on here. But you'll notice there's some form of application. So here's a couple of ways you can write it. So I wrote mine a little bit different up here. So some of you are going to choose to use my method. So 2 pi r times a divided by 360. It's the exact same formula as what you see here. But I just want to point out a few other options. So angle alpha, this is your official definition if you want to write it down. Angle alpha is the interior or the central angle with a radius r. So if we're talking about a sector of a circle, a sector is the pi piece, and we're looking at the length around the arc. You have two formulas, and you do need to know these. They're given to you in your formula packets, but you need to know them for tests, quizzes, and homework, and all the above. So here's one option, and here's another option. And the other one is the one I gave you, 2 pi r times a divided by 360. You can use any of those methods. They're the exact same formula. And you could say, well, the second one looks totally different. Well, if you take the 2 and the 360 and you reduce those fractions, you end up with 1 over 180. So that's kind of where they came up with that one. So I am moving forward actually going to be using this one here, alpha times pi r over 180. But I wanted you to see where it came from. And the reason I use this is it's the most simple, it's the most reduced, and I don't have to deal with as big of numbers. So A is the angle, R is the radius. You only need two things. So angle, radius, and then you get your arc length. Okay, so there's that. Let's work it out and see how it works. All right, find the length of an arc of a circle with radius 2 centimeters and central angle 120. So what you have here, you don't even need to draw a picture if you don't want to, because they give you this, that's your alpha. They give you 2 centimeters, which is your radius, and they're asking you to find the arc length. So arc length equals, and if you use your handy dandy formula from above, you get your alpha, I'm going to write the whole thing, alpha times, you remember, please, pi r divided by 180. And then you just substitute the things you know. So, by the way, if you ever struggle trying to figure out formulas and how to use them, do you notice that I just wrote the formula here? I didn't even put anything in yet. It's a good strategy. I'd recommend doing that in your notes and your homework and every time you need to use it. Start out with the formula, substitute the things you know, and then solve for what you don't. So the 2 centimeters goes in for r. So let me write that out. So we know alpha also. So 120 times pi. 2 goes in here for centimeters divided by 180. And then we know we're trying to find the arc length in this case. So I'll call it AL, arc length. So now let's figure out what that is. And I can use Desmos once again. So 120 times pi times 2 over 180. Let's go Desmos. Oh man, look at all these things from earlier. Fun math. What are you doing on Friday afternoon? I'm doing math. It's so fun. Okay, so I already forgot my numbers. I think it's 120. 120 times pi times 2 over 180. Let's do this. So 120 and times, times, and then I need some fractions here. And I had pi, so type in pi or just get the pi, times 2. And the whole thing is being divided by 180. And check it out, I get 4.188790. That's a big number. But remember, in IB, how many significant figures do we use if you don't know? And I don't think the problem says. It doesn't say, how many sig figs, class? That's right, 3. 3 significant figures in IB. So we have 4.18. That 8 says to that 8, go up to a 9 because it's closer to 4.19 than it is 4.18. So 4.19 is going to be our answer. Let me write it out. So our arc length equals 4.19, and I believe it's centimeters. There it is. That is how you find the arc length. So basically what we had here was 120-degree angle, so we have a circle. If somebody walked around 120 degrees, what would that be? Not quite all the way around. Let me erase that. So actually, let me draw the whole circle. So here's a whole circle. Somebody is hanging out. Here's the center. So they started here. And they walked all the way around to about here. So this distance here, 120 degrees. Okay, so there you have it, folks. That's how you do arc length. Enjoy.